You all right?
You cut me.
I meant to.
You meant to?
I think he was gonna let you off without a scratch. I'd still be standing there if I hadn't hit you.
We've talked about how you take this prediction equation and slice it up into the different categories. Let's go back to that output and talk about how to read it. For starters, let's go back to this plot, and I hid this picture last time, but here we go. Now we can see the red and black dots. What's happening here? Interestingly, more red dots up here, fewer red dots down there, which tells us the men tend to be older in the company. That's part of the reason why they're getting a higher paid salary. Is the slope and the intercept different? Looking here at the output, we have women's starting salary. Is it different from 0? Who cares? That's not even an issue. So that p-value doesn't mean much. This right here says, here's how much of a promotion women get per year. Is it greater than 0? Well, sure. But also, again, that's not necessarily a shock. That tells us the longer you're in the company, the more salary you get. Here is the change in the y-intercept. That's starting salary for men. Is it different than women? Yes, it is. It's not just luck. It's not just people we put into our random survey. There is a significant difference between the starting salary for men. They're getting 8.5 thousand higher starting salary. And as far as promotions, they're getting 0.394. This is in thousands, so an extra $394, almost $400 more on average per year. So their promotions are a little higher. This is important because a bank manager's first reaction is going to be, well, you showed men are getting a higher salary, but that's just luck based on who you picked. If you redid this survey, then you'd get maybe women are higher. No, it's not just luck. There is statistically provable evidence that men start at a higher salary and men get more per year. No, it's only because the men have been in the company longer. No, we've accounted for that. This is the effect of the slope. Men have a higher slope. Let's look at those lines. Let's make some hats for our x variables, and then we're going to have two different y variable, that's salary, both for men and women. And to get these prediction equations, we're going to use the same numbers that I wrote on the board in the last video. For women, they use this intercept, and they use this slope, but this number's for males and that's for males, so that doesn't show up in the women's equation. It shows up in the male's equation. Here's the intercept, and here's the change that comes from being male. We also have the slope, and we're going to take that slope and add to it the slope effect from being male. So here's our two prediction equations. If I want, I can simplify the males the way that we showed in the last video. It's mathematically the same, but sometimes it's nice to see here's y-intercept slope for each of the two groups. So now I'm going to plot the line for females and see if it matches up. Now I happen to know that the female dots are black, but what if you forgot that order or weren't sure? Well, I can ask R to tell me the order that it's put these in. This is bank $. Gender is female and then male. Notice it's in alphabetical order, and R does that on purpose. So females are going to be the first category, males are going to be the second category. That's why up here in our output, male was put second, because it came last alphabetically. R has a specific order for the colors, that's palette, and it goes black, red. If we had a third group, it would have been green, and the next group would have been blue. So for us, we have the black group is females, the red group is the males. So when I draw this line for the females, I'm going to color it black, which is what it would have done by default anyway. And I want the line to show up on your plot, so I'm going to make it a thick line. Oh no, salary hat F. Oh, that's because I made this code, but then I didn't run it. That's a common mistake. I'm trying to decide if I should back up the video so you don't see that, but it's a common mistake. There we go. The female, here's their starting salary, and you can see their promotion level per year. Let's do the same thing with men. We're going to color them red because they have the red dots. Red being for the second category. Second category is male. When I run the men, I get a different line. I get that I obviously have not run that line of code yet. Yeah, well, I get to pause the video for like 30 seconds. Here's the problem. It's year hats, not years hat. The reason is because when I put the S in front of the hat, suddenly some of those students start giggling. So There is my salary hat, and there is my line. Do men start at a higher salary? Yes, you can see that on the plot. Do men get more promotion per year? And yes, because their line is just a little bit steeper. Is it just luck? No, it's statistically significant based off the p-values. Yes, there's gender discrimination, and no, you can't excuse this just by saying it was a random fluke and not actually provable.